3, 2, 1.
That's sick,
Yeah,
man.
Hi guys, welcome back to Thornton 100 Motorcycles YouTube channel. My name's Jody, this is Alex, my CAD designer, and we have designed what we think is the best, most well-engineered and tidy and neat package for putting a passenger safely onto a Triumph Bonneville bobber. And in this video, we're going to tell you exactly how we did it. Right, well Alex, passenger seat for the bobber. Initially we were going to make this removable, weren't we, this passenger seat?
Yeah, we're just going to go off of bolt points further up and everything.
Yeah, so yeah, I mean, it's been an absolutely mad one, but as we'll explain later and you'll see why we couldn't do that. Now, what we essentially did was we took this kind of trunk here that kind of comes up from underneath the seat, and we brought it up and extended it. So I guess the way that we tackled it initially was, like you say, just get that up here, agree on the contact points with the bike.
Yeah.
So we came up with that 3D print down there.
Yeah, this was Mark 1.
Yeah.
It's kind of just boxed out, but it did the job, and it allowed us to talk about it and hash out some ideas. So the customers, like, initial brief was, can you make it safe? Can you make the passenger feel comfortable? And this angle is just, I think it's a couple degrees, and it just pushes that passenger forward onto the back of the rider.
And it fits quite well in the aesthetic as well, because it kind of swoops down into the seat here, doesn't it?
Yeah, I think we did a pretty good job of making it OEM.
This whole seat design here was a really interesting one, wasn't it? Because I remember saying to you, like, okay, we've got this long tang. We can't sit on the tang, you need a seat that kind of sits on it. My idea behind this was having no bolts, and then we bolt our support plate to the tang, and then off the top of the support plate, we needed a way to stick this onto here without bolting it from the bottom. Kind of came up with this kind of, these pins here, so there's a locating pin here, and then there are receiving holes here. And then we also have the locating square that you came up with the square, didn't you, at the back there?
I liked it, yeah.
Yeah.
4 sides, nice and simple, it'll lock in rather than kind of a rounded point that could pivot.
Yeah, that's it, yeah. So the square is kind of cool, and basically we have bonded neodymium magnets in here. So obviously positive and negatives at the bottom, and then receiving on the top. So what essentially happens is you kind of hold it in place like that, and then it just locks in. So there is, how many kilos? 30 odd kilos of pull force holding this down. If you manage to kind of lever it just right, you can get your fingers underneath it and pull it up. So by the time you have a passenger sat on here, obviously if you go for a bump and their bum bumps out the seat, this wouldn't come up and then disappear down the road, and they'd be landing on something that is not meant to be sat on.
No, definitely not.
So, you know, that was an interesting one. And also what it means is that square there and then these two prongs stop it from twisting. So, you know, you can't come off it backwards, you can't come forward, you can't go off sideways, and it won't come up unless you really intend to pull it up. Obviously, with this design compared to the first one, one of the main differences is this kind of spine which kind of comes up the back, and I think we can show it on this one. So we have this spine which really comes up and brings that down there, whereas on the first print we didn't have that, did we? No. Now, that wasn't strong enough. If we'd have sent that out, realistically that could have snapped and someone could have lost their life, you know, kind of thing. So very, very, very serious matter for us, you know, it goes into all of our parts. But had to be taken into account, like even more so, it was even more of a poignant point on this one because you are just sat over the rear wheel. Right, so I'm going to give that to you, Alex, and you can show these guys a little bit more about the stress analysis process.
So for the stress analysis, we've got this really good software I'll show you guys. What it allows us to do is load the part in the way that it would be in real life and essentially see where the weak parts are. So you've got this kind of heat diagram, and I'll show you guys a little closer. What we've done is we've created 2 loading points, front and rear. Obviously you've got the rider and their passenger. Due to the cantilever, this creates quite a lot of stress throughout the part. This is like really evident at the back here. So this is in a deformed state. This is if it was to break, and it kind of shows you at the heat map what parts would move the most, red being the most, blue is not moving at all and it's all safe. So from this, what I'm able to do is take the information, take the data, and make an informed decision about my design. And it's just so useful. Like, this is V1, it hasn't gone external. For all stress test analysis, we always go external to make sure our parts are so safety, like secure. And you can see again here, exactly where we've got those arms, that's the stress points. So we had to work on this a bunch. So we do this internally at first, and then we send it off to the guys, and they send it back and they say, Alex, you need to sort this out, you need to make it better, do this. And that's kind of where the spine came about as well. That was not something I thought of at all. And again, it looks wicked now. We made it look sexy, so overall pretty good. Another exciting feature of the passenger seat was, thanks to Jody coming up with the magnet idea, we've got this kind of modular platform which it allows us to do so much more with. So we're thinking like luggage racks and cowling if the person wants it. You know, they don't want someone on the back all the time. You got options, you know. So we're going to delve into that, I'm sure, in a few months' time, see what we come up with. We're going to jump back now to having a look at the final product. As much as it was like a challenge, it was a really fun part to design.
Yeah.
I think the way that I went about it was, the engineering always came first. So this ridge, this spine, it came in, and then it was kind of a, like, how do we make it look pretty kind of task.
Yeah, so I think one of the main parameters that I kind of set was, I want, right, so we standard Bob, you got 120 kilo maximum rider weight. I want the same for the passenger. So altogether we have 240 kilos here. We apply a 3G bump force that gives us 720 kilograms. And then we actually got to a safety factor of 2.9 before we go into any sort of failure mode, which allows us to put 2,088 kilograms on this before it starts to deflect past the point of what it's supposed to deflect by, and we'll start to go into any sort of failure mode or develop any kind of creep or symptoms like that.
Yeah. So not snap, but just default.
Yeah, that's it. So it's a
at 2 tons.
At 2 tons. Yeah, that's not breaking, bro. Is that good?
Yeah.
Stevie, I think you should do a backflip off it. I think I should sit on the bike and you should do a backflip.
Well, outside or in here?
Outside.
Yeah.
Yeah. Yeah, that'd be a sick photo.
Oh, that's gonna be weird, man. Okay, ready? 3, 2, 1.
That's sick,
Yes,
man.
boy.
That's sick. I can't fist bump you, but.
Thank you very much for watching, guys. That's our passenger seat, a little bit of a behind the design there. I'm really happy with it.
Customer loves it.
Customer loves it, everyone's happy, so it's all good. When we get to 100K, we got a very special giveaway for you guys, so absolutely do not miss it. Make sure you're part of it. So make sure you subscribe to this video. Thanks for watching, and we'll see you soon.